All right, welcome everyone. So we'll get started with our February CoE steering committee meeting for Autoware. So we have quite a bit of updates for you. So what we'll do is in the first 20 or so minutes, we'll have a series of updates and then we can have a open discussion after that for the remaining time. Uh, so one of the topics that we will cover today is the Autoware tutorials that we will have at IV in Korea later in the summer. And so we have some of the presenters who will provide some updates. And I'll begin with having Pojan give an overview of some of the activities that we have been up to in the CoE, and then we can move on to the tutorials after that. Then there are quite a few other updates that we will go through with ICRA and other activities we are organizing together.
Thank you, Rahul. So let me share my screen. Okay, can you guys see my screen now?
Yeah.
Oh, not this one. Oops. Sorry, I'm trying to click on the tab, but I mean this Zoom this like a status bar is blocking it. So let me unscrew it. I'll share it for now. Okay, let me share it again. Okay, you guys see my screen? Hello,
yes,
can you guys see my screen?
Yes.
Okay, so first I will be giving you some updates on the go-kart. So these are like an overview of what we have done since the summer of 2023. So we have made a lot of improvements on the go-kart on both hardware and software side. So first, the first improvement that we made is that we have replaced the stock brush motor from the go-kart with a brushless motor with a new VASC. So the reason that we do that is that the previous brush motor can only drive in one direction. So previously, when we want to back up the go-kart, someone has to manually push it. It is kind of dangerous because someone has to stand in front of the go-kart and then push it. So we wanted to replace it with a motor that can do both forward and reverse direction. So we replaced the motor with this brushless motor with a Hall effect sensor and a new VASC. So the team actually spent quite some time getting everything working. So we encountered a lot of issues interfacing the VASC and the motor. And then we later also found out that we have to rewrite a lot of the code for the PID controllers because the old code for the old motor doesn't work well with the new motor. But finally everything started to work early this year. So currently the motor is no longer blocking us for testing the go-kart. So for the next improvement, we have also redesigned the rear shelf of the go-kart. So on the left image, you can see that is the old design from last year. So basically, we have these two levels that we use to mount the electronic components, and then we use these horizontal T-slots to mount the 3D lidars and the antenna. But we have basically lowered everything. Well, for the two levels, we have lowered them so they are closer to the ground, so that slightly lower the center of gravity. And then we have replaced the horizontal T-slots with these vertical ones to mount the lidar, and we also added some cables for suspension. So it is a generally more sturdy and also more compact design compared to the old shell. So So these are the second improvement that we have made on the go-kart. And then since last year, we have also spent a lot of effort documenting everything, the hardware and software for the go-kart. And then we have covered this before, and then we are super grateful to get all the feedback from the Korea CoE as well as from Honda. And then we will continue to update on this documentation. And then next, so this is a ongoing project. So in addition to all the hardware updates, upgrades, we wanted to build our own go-kart simulator. So the goal is that we want to be able to test all the software algorithms, the planning perception algorithms in simulation. So we are not limited to let's say weather or space, and also like at the Innovation Center that we usually test our go-kart, it's the space is actually not that large, so we can't really test our algorithm at high speed. So we really wanted to have a simulator to test our system. So first, we created a digital twin of the Innovation Center environment in Blender. So this will be like the main test environment in the simulation. So you can see the red building in this image. So this is the Innovation Center at UPenn. So the Autoware lab is actually one of the room on the first floor of this building. And then usually we would drive our go-kart along the sidewalk to this open area and then do all the testing. And then, so basically we started with mapping everything in Blender, mapping all the areas that we usually test the go-kart. So that's what we have on the right side. So on the left side, so this is the 3D view from Google Earth of the Innovation Center. And on the right side, this is the 3D rendering of the Innovation Center that we built. So later we decided to actually expand the regions that we're gonna model, because last year we got a EVE autonomy kart platform, so we are not really limited to a go-kart. So we're gonna have a different vehicle. And then we found that if we are able to map these parking area, it will be also very useful for testing both the go-kart as well as the EVE autonomy kart vehicle in the simulation. So we spent some time creating like these curves and mapping them, creating the parking lots. So now with all the additional areas, we can easily create tracks for like racing, or later we can also use these parking lots for like testing some parking maneuvers with Autoware. So these are some great additions that we have compared to just using just the front areas of the innovation. So we have mapped the environments. So we also need to map the 3D model, the go-kart. So we begin with the CAD model that we have from SolidWorks, and then we spend some effort trying to simplify the model, simplify the geometry, and then you can see on the right side, this is the go-kart model that we have. And then there are still some components that is missing. So we are still trying to add more steer-by-wire components. We also want to not like overcomplicate the model. So we will try to simplify everything. We will try to add some like mock-up for those steer-by-wire components and try to add them onto the 3D model later. So basically, all the environments and the go-kart models can technically be imported to any simulator. So we have many options for the simulator, including like Awesome or other simulator. But currently, we are working with integrating everything into a simulator called SodaSim. So SodaSim is a open source a simulator for testing like ADAS systems, and this simulator is based on Unreal Engine. So another reason why we decided to work with this simulator first is that currently there developer from this company that is directly working with us with the integration, so that can really speed up the process. So with this simulator, all the important components like simulating the vehicle, sensor, ROS2 interface are all included. And this simulator currently supports both Ubuntu and Windows. So when it comes to simulator, it's all about the dynamic model for the go-kart. So because this simulator is based on Unreal Engine, that is a popular game engine. So there are many like models that can directly be integrated into the go-kart. So so we see that there is already a simple like a bicycle model that we can use on a go-kart that is great for like initial testing of some of our planners. And we also learned that they provide some like very advanced models that come with like over 50 parameters that we can tune. So later we can try out these more advanced models on a go-kart as well. And on this simulator, it also has some built-in like AI agents. So it has some like AI drivers that can directly control the vehicle. So we don't need to. So it already comes with some capability of like driving the vehicle by itself. And then one of the important features that we like about the simulator is that this simulator provides some tools to generate track with just the JSON file. And I was told that this JSON file is compatible with the map file from F1Tenth. So technically, the map file can be like converted between F1Tenth and this simulator. On the right side, these are just some parameters that I got from the advanced model. So it has a total of like over 50 of them. So I'm just showing part of them. So we can control like the engine, a lot of parameters like for the engines, for the chassis, as well as like brake and suspension. So here is a video of the initial integration of our go-kart in this simulator. So you can see, well, actually, like Rahul haven't seen this video yet, so I just got this today. So you can see like he's trying to load a JSON file, and then it will build a track using that JSON file. And then it is trying to load our go-kart. So here's a list of the components that has been added to the simulator. So currently the control inputs is set to keyboard. And then we are now like controlling this go-kart like manually with the keyboard. So you can see the keys that is being pressed at the bottom of the video, so WSAD. Okay, so the next video is it shows like the ROS2 interface and also like the generated sensor data. So you can see all these I believe these are the point clouds from the LiDAR, and then we are showing the camera feed on the right side of this video. So that's the camera feed as well as the point cloud data from Orbis. Let's play that again. Yeah, do you guys have any question or comments?
Yes, Pojan, this is just really cool. I hadn't seen this video yesterday. So what are the now this vehicle model? What type of model is it?
I believe we are currently testing the bicycle model. So we don't want to touch the advanced model yet. So we're just playing with the bicycle model.
Okay, and then what are the now, going forward, what are the plans for using this simulator so that the code that runs in simulation can be used in the car also?
Okay, yeah. So I think I have a slide for that. So these are like the next steps. So next we will import the Pennovation environment into the simulator. So that shouldn't take too long to do. And then next we will start recording and building the point cloud map from the environment just by like manually driving it. And then next, once we have the point cloud, we can build lanelets using the point cloud. We can define lanelets maybe in the driveway and the parking areas. And then next, I think we can start testing like the full stack Autoware without these data, without the maps and lanelets that we have. So the next will be Autoware integration, testing everything in Autoware. And then finally, we have some existing algorithms that we developed for F1Tenth or the Go-kart that we gonna import them into Autoware as well. So these are kind of the next steps, and then we can do all of these in both simulation and in real life. In addition to this, there are some other like lower priority tasks. So we also plan on optimizing the 3D model more. So we found that some of the components are still has too many like faces and vertices. We want to reduce the number. We want to reduce the complexity of the geometry, so it will be easier to render. And then we also plan on creating the Purdue track for testing everything for the competition.
Great. So, and I think by that time, Armin and his team will also be able to then they'll resume their work on the go-kart, and then they can import the Zalazone track.
Yes.
Absolutely.
Yeah, and I think as Jin and his team are building the go-kart in South Korea, and there's a team even in Tokyo building the go-kart, and they can avail of this, and will provide guidance on how to basically use this simulator to save time and frustration.
That's great.
Okay, guys. Any other? This is a very good update, Pojan. Thank you. Any other questions for Pojan?
Just to confirm, Raul Pojan, so under step 4, you're going to use, stock Autoware universe, kind of get that going first, and then in 5, fold in some of the F1Tenth racing add-ons. Is that correct?
Yes, I think we're gonna like test everything in parallel. So we're gonna test the stock software stack as well as testing some existing ones that we use on F1Tenth. So.
Well, that's awesome. Nice work. And then on board for the compute right now on the cart, I mean, obviously you could use a laptop or whatever you wanted, but are you thinking just the AGX Orin? Because I don't know how that would do with all of Autoware, but what's the compute on board?
Currently we are still using a laptop, but we are trying out with the like Orin Nano, but we aren't sure if that has the compute power necessary for running everything. So we're just gonna do more testing and then see which one works out. So
sure.
Just one comment from our side. We purchased an AGX Orin as an onboard computer for our version of the go-kart. Just as a side note, so maybe we can also play with that later on.
Hi, I have a quick question on step 2. Are you building the point cloud map with the data in the simulator or from the real world?
I think we can do both. So in the simulator, we can have one point cloud map, and then in the real world, we have another one, and then we can kind of see like what kind of are they like matching each other? Then that like tells us like how accurate our 3D model is. So
Okay, and will there be any additional connection between the real world and inside the simulator?
so like one feature that I'm thinking is that like maybe in the real world, like once we do the localization, maybe we can plot everything like as a UI. We can plot everything in the simulator like in real time. So that kind of like display the pose of the go-kart in the simulate. I mean in the virtual environments. So
Okay. Do you have an email address where I can send one of our papers to you? Because we have this we have a paper that focuses on step 1, 2, and 3 that I think might be useful for you.
Oh, nice. Yes. Yeah. So yeah, I think I can give you my email. So or maybe like Rahul can like give you my email right now. So
Yeah, I shared it.
Okay, I got it. Thank you.
yeah, thank you. Yeah, appreciate that.
Great. Thank you for the update, Poojan. So now we can move on to the Autoware tutorial that we are planning at IV, and then maybe we can start with Kanghee and then Simon, and then come back to Poojan.
Okay. I will stop sharing my screen. So
Okay, this is Kanghee from Thompson University, and can I share my screen with you?
Yes, go ahead. Yeah, just an introduction. The Autoware tutorial and the Autoware workshop at the IEEE Intelligent Vehicles conference in June, in early June in Jeju Island in South Korea is really almost like a annual meeting for the Autoware CoE, and I highly encourage all the CoE members to try to come there. Obviously, it's a long journey for many of us, but this is a good meeting place. We had a really good get together in Alaska last year, and Alex will also later follow on with having people give talks and for the workshop. But the tutorials are basically really showing Autoware running on variety of platforms, and they will provide some hands-on guidance for the community. Go ahead, Kanghee.
Okay, thank you for the introduction. I will give you a brief update on Autoware on F1Tenth Premium. It'll take just 3 to 5 minutes. I will give you a quick summary. We have developed an enhanced version of F1Tenth for auto driving, which we call F1Tenth Premium. Recently, we have revised the F1Tenth Premium hardware. We changed it 64-channel LiDAR to 32-channel LiDAR in order to lower the BOM price. And we designed a new protective case to protect the vehicle from crashes on F1Tenth Premium, and bringing up as many components of Autoware Universe as possible. We are a little bit behind the schedule, but I think there will be no problem in presenting our hands-on lab at Autoware tutorial. Currently, we are testing localization pipeline. This is in progress, and we are as soon as we finish a localization pipeline test, we'll move on to planning and control pipeline test. This is the demo video I already showed you 4 months ago, I think. So I can skip this video. And right now we redesigned the apparatus and changed the LiDAR sensor. The original F1Tenth Premium was, I think the rough estimation of BOM price was $16,000, which is very expensive. The expensive part is the LiDAR. So in order to lower the BOM price, we changed the LiDAR from OS 164 to OS 132 channel. So we can save the $5,000. And originally our plan was to attach a camera from TF4, C1 camera, but this camera is not ready. I contacted TF4 several times, but currently not in South Korea. Our computer is NVIDIA Destin AGX Orin, and we, as I told you, we revised the apparatus to protect the whole vehicle. So just in case if our vehicle is flipped over, we want to alert our LiDAR not to damage it. So this is the reason we redesigned the platform deck and protective case. This is the progress of our software porting. Building Autoware University is done. Planning simulation is done. And we are now testing localization pipeline with 2 PCD maps. We have 2 different maps. PCD map 1 is a kind of a reference map with a high precision. Actually, this map was composed by HDR Graphics Lab using a sensor recording data set obtained from Hosai Pandar 64 LiDAR and RTK GNSS. Actually, this sensor kit was mounted on a full-size research vehicle. So PCD map on is a high precision, but we want to make a PCD map with only with the Auster 32 channel LiDAR. So we composed the PCD map 2, which is a low precision. In that case, since we don't have high precision IMU or autometry, we only rely on a LiDAR sensor to build up a PCD map 2. In that case, we build up this map. We compose this map with a series of entity mapping and a manual loop closure with cloud compare. So this is not a graph slam, and we are using Autoware 32 channel LiDAR. So we are testing the localization pipeline, and we are now evaluating the localization accuracy, but we are waiting the result. So this is in progress. After that, we will move on to testing, planning, and control pipeline, and performance evaluation and documentation. This is the map we composed recently. The upper right-hand side, there is a PCD map. This is built with under 64 channel and graphics lamp. The lower figure shows the PCD map built with OS 132 channel plus manual loop closure. So the bottom figure shows lower resolution. I mean, of course, we can improve the quality of the map, but anyway, we are trying to compare these two maps in terms of localization accuracy. So this is the final slide. This is just a planning simulation. So this is our campus map. Yeah, planning and control. I mean, in planning simulation. So yeah, that's all.
Great. Thank you, Kanghee. So what do you use for this powertrain testing, that test bench that you have with the
You mean the power board?
no, like the underneath of the
Yeah, actually,
you had that video
could you
that
please?
showed the car was stationary, but the wheels were being moved, right? So with the
I mean this video?
yeah, so what do you have as the base of that for the test bench?
What do you mean by base? I mean,
That's rotating the wheels of the car.
you mean the dynamometer?
Yeah. So did you custom design that dynamometer or?
Yeah, of course. We custom designed the dynamometer.
It's very nice, yeah.
Yeah. We also share the design. You can also share the design. So yeah. So if you need this kind of dynamometer, actually, in our dynamometer there is no sensor to count the number of rotations or acceleration. No, there is no such a sensor. But anyway, it can help the vehicle move in place.
Yeah, that would be good to bring for the demo also. Yeah.
So right now we are trying to integrate everything in Autoware universe, and then sooner or later we can do auto driving with our F1Tenth Premium. So of course we will share all our experience at Autoware tutorial.
Cool. Thank you. This was a really good update, and very excited to see this in IV also. Yeah.
Thank
Okay,
you.
great. So we can move to the next person who is covering the tutorials. I think Simon, you have any update?
Yeah, I can share an
Okay,
update.
yeah, go ahead. Then
Okay. Can you?
Oh yes.
I'm getting yeah, it's disabled the sharing.
Yeah, go ahead.
Okay. Okay, can you see that?
Yeah.
Slideshow? Yeah. Okay. So this is an update for my colleague David Wang. He's away on business at the moment, so he couldn't make this update. But for the IV conference, he is going to present a tutorial on the Nebula sensor driver. So the tutorial is going to be an introduction to the sensor driver and tutorial on how to adapt it to other sensors and how to contribute these sensors to the project. So the idea of the Nebula driver is an open source driver solution targeting Ethernet connected sensor devices. And at the moment, it's concentrating on LiDAR devices. And it's the motivation for it is that when new LiDARs come onto the market, the ROS or ROS2 support for their drivers can be of more or less good quality, and the implementation can differ slightly, and it can also be difficult to know how things like synchronization and time stamping of individual points is done. So to have an open source driver that has some shared components can a little bit more make the performance of the center drivers similar for each different product. I think this is a good project, and they've made a lot of progress on that within Tier 4. And I think even now that the Nebula source code is included in the Autoware Universe distribution at the moment. So I'll just read off these things. It's a flexible architecture that provides transport layer implementation and templated sensor decoders and hardware interfaces. And the sensor decoders are available as libraries with a ROS2 head for integration into Autoware. And of course, this is meant to be easy to use with Autoware for all supported sensors. And then it's easy to add a new sensor implementation by the community. So to make to integrate a new sensor, this is the information that's required. The data structure information normally available in the data set, such as UDP, data packet data structure, and diagnostic data packet structure. And the control and diagnostics interface through TCP and HTTP. The above information must be openly available, as the Nebula will not include proprietary binaries. And they also need to supply a sample packet data for unit test implementation. So this is the kind of parameters which are configured. The return mode, and this is specifically talking about LiDAR sensors, obviously at this moment. Return mode, frame ID, and scan phase, and there's some testing environments. So the tutorial will introduce these concepts, give an example usage, how to create launch files for it, and how to integrate into Autoware with a new sensor. And in detail, they'll discuss about adding a particular sensor, introduce the code structure of the Nebula, and explanation of the templated decoders and feature mixins, and how to add your new sensor port with step-by-step examples. Yeah, so that's briefly the introduction to the tutorial, the concept of Nebula, and the details of the tutorial. Okay, thank you. Thank you.
Thank you, Simon.
Yep.
This will be a very interesting addition. So yeah. Besides Pojan, anyone else have a tutorial topic? Just want to check. Okay, Pojan, you can go ahead.
Okay, let me share my screen again. Okay, so I've only prepared like three slides for like going over the overview of the tutorial. So I'll be presenting for session 1, so Autoware on scale platform. So I'll be going over like how to run Autoware on 2 platforms. So that'll be the 1/10 scale F1Tenth race car, as well as the half scale go-kart platform. So because I'm gonna talk about like 2 platforms, so currently I'm planning on like spending like splitting the time like 50-50, like spending half of them on F1Tenth and then the other half for the go-kart. And for the F1Tenth, I will like cover how to install Autoware on Jetpack 5. So that is the older model that uses Jetson Xavier NX. And then I will also briefly talk about like the installation differences for Jetpack 6. That is for the newer Jetson Over Nano. And then later I will like cover how to run the record replay demo in a simulator, as well as like how to run it on a real car. So depending on the environment, I'll decide if I can like actually build a track. I mean, build a map and then run the demo on a real car, or I'll just play a video of the demo. For the go-kart tutorial, I will focus on just like installing and then installing Autoware as well as the simulator. So I will be focusing on only the simulator. So obviously not the real car, not the real go-kart. So I'll be covering like how to install Autoware, as well as how to install like Unreal Engine, as well as the simulator, and then how to run a simple like a simulation demo with Autoware. So here are some more detail. So here are some of the items that I will cover in the tutorial. So for the F1Tenth, I will begin with a brief intro. What is F1Tenth? It's a low-cost platform for AV research. And then here are the steps to install everything on the Jetpack 5. So we need to flash Jetpack onto Jetson. We need to install ROS2. We need to create swap file and then install Autoware. And then we need to install some of the packages from F1Tenth. So there will be the simulator as well as the SAM toolbox for creating the map. And then I will go over like what are the differences in the installation steps for installing on a Jetpack 6. It should be much simpler. So should have less issue with Jetpack 6 because it is running on ROS2 Humble and Ubuntu 22.04 that matches the Autoware version. And then I will discuss what are the packages that are being ported to F1Tenth. So that will be the perception packages because we are using different LiDAR. Instead of 3D, we're using 2D LiDAR. And then I'll show like how to run the record replay demo. So that is basically you'll build a map by driving the F1Tenth car manually, and then record a trajectory, and then we can replay that trajectory. So this is the items that I will cover for the F1Tenth demo. And then for the go-kart, again, I will begin with a brief intro about the go-kart project. So it is a open source project for half-scale platform for AV research. And then I'll go over like how to install everything on a PC. So we will have to install Autoware. We'll have to install and then build the Unreal Engine from source for Ubuntu. We will have to set up Visual Studio Code and then install the extensions for C++ and C#. Then we'll need to download the maps for the point cloud map, as well as the 3D model that we created for the Innovation Center. And then we'll need to like create a Unreal project and then install the SodaSim as a plugin. And then again, these are still work in progress. So we're still working on the simulator. So these are just the steps that I think will need to be covered. And then next we will have a Autoware simulation demo. So we plan to like just run a simple demo running Autoware. So like similar to the demo in the Awesome. So we will run the full Autoware stack, and then we can like set up a goal post in Orbis, and then the go-kart should like follow the net and then reach that goal post. So this is the plan that I have for the go-kart tutorial. So yeah, that's all I have. Do you guys have any question?
Maybe not a question from my side, but rather a question whether you need any support in these tutorials, because maybe also from our side, somebody can support you, maybe even on site in Korea, if that's necessary. Just let me know.
Okay, yeah, I think I'll maybe do a few rehearsal myself, and then making sure that I have enough time, and then everything works out. So yeah, I will let you know if I need any help. Yeah, thank you.
Thank you.
Appreciate that.
Great. Thank you for the update, Pojan. So in the next CoE meeting, we will have updates from Lema's group and others who are also providing tutorials. This is just so that we are getting prepared for it. Right. So and then these will all be published on the Autoware site, and we would want to use these tutorials as part of like broader training material. So other quick updates that we have, so we will also be hosting the F1Tenth autonomous racing competition at ICRA, and we invite all folks to come and join and participate in this, and also there'll be several folks in Japan who will help with planning and organizing this. And we were from F1Tenth, we also invited to the IROS competition, and they want to look at more like off-road driving, and so that would be the follow-on to that. But ICRA and IROS would be the two large competitions that we have besides the IV and ITSC, and a final competition in December is also being discussed with the organizers of CTC, the Control Decision Conference. That will be in Italy, and so the University of Modena folks are keen on organizing that. So yeah, so please share this and also join in. We'll also have a workshop associated with that in ICRA. Among the folks here who are planning to attend ICRA this year, anyone? Yeah, I know Kanghee, you said you would come, and then yeah, so I think the other update with Kanghee, Kim, and is that we will also try to we'll also plan to submit a joint demo proposal. So ICRA has many demonstrations, and we would like to have the pics moving with David's and Alex's efforts with pics moving, have their platform, have and then have Kanghee Kim's F1Tenth Premium, and so let us know if you would like to be part of that. It's just a 2-page demo proposal, but we would like to show that Autoware is running across multiple platforms, and I can also just share the invitation that we for the demo. So that right, so the ICRA expose and this yeah.
Is that demo? It's just it's a static, just exhibition, and
I mean they usually have they usually have a lot of legged robots and some flying robots, and so they want to see some action like that, right? So yeah. So there are companies that buy the booths and come there, and then this is more like the academics providing like demonstrations, and so I shared the link in this, and so we will submit this shortly, and then yeah, I think the deadline is coming up. It's March 14th for submission of this, and it's just a very lightweight submission, but we'll coordinate that together, so we submit it as a team then.
Sure. Thank you.
Yeah. All right, so I think we'll just open the floor now to everyone to any updates from your side. We can just go around the room to provide quick updates. Yeah, Samit or Johannes, any updates from your side?
Rahul, from my side, we were discussing for some potential OpenAD demos in one of these prestigious conferences, and we would like to explore those with the vehicle platforms that we have, Pixmoving, for example. And I'm intrigued with the iCross submission, so I'll probably talk to David and Alex about that one. We promised that we would put the OpenAD kit on real vehicle, so that might be the case. And also you mentioned IROS, that's in Abu Dhabi, right?
That's right, yeah.
So Pix guys have the Pix kit around the world, as far as I know, right? The India, in Japan, in other places. So hopefully we will pull some OpenAD kit demos there too. And earlier today at the software working group meeting, the Tinker Twins stopped by at the software working group to talk about the auto drive for the F1Tenth simulation. I guess you also talked to them for integrating their work, right?
Yes, yes.
Apparently, it's a huge PR request, and the technical staff was asking me about making it into smaller chunks of PR requests. But I'm talking to the India Autonomous Challenge for they want to collaborate with F1Tenth. In that case, I'll still make the introduction for you and Mark. But I have seen the simulator Pojen showed. Is it on a Soda Sim? Are you considering maybe running F1Tenth simulation in Soda Sim or Autodrive or something like that? There's a little bit of overlap. What I've been working on a little bit. I can also write to you offline.
I think for F1Tenth, yeah, that is definitely an option. But I think I can discuss this with Rahul and then see like what simulator will be the best for this F1Tenth platform. So yeah, we definitely have many different options to go for. So yeah, we just need to play with maybe each of them and then find the one that is best for us. So.
Yeah, there are many simulators around with AWSim and some are suitable for urban and some are better for like the racing. I think yeah, just kind of building some specific solutions and then sort of reducing the noise after that would be an approach here.
That's good. I'll start a thread between us. Thank you.
Cool. And any other updates from other members here?
Hi, hello. If I'm just
Yeah,
comment quickly, the Autoware workshop at IB, the paper submissions review is still ongoing. Different from the past 6 activities that we have organized, for the past 5 activities we organized, and this time the program chair decided to assign the AEs, the associate editors, not from the pool of proposed of the organizers of the workshop. So I have no idea absolutely how the final tally of the number of papers that we received. I know that it's around 6 papers, maybe hopefully more. And how it's going to be the review process is the only thing that's a bit puzzling, because other AE may have been assigned to review papers related to Autoware, and he or she may have no idea whatsoever about Autoware. So that's a bit puzzling about the decision of this version of IB. But yeah, we will let you know how the things go. And yeah, really, as Rahul mentioned before, this is the activity that helps our network, the COEs, to get together. So hopefully we'll see many of you during IB, and we'll hope to get a lot of presentations for you guys. Thank you.
Cool. Thank you, Alex. So we will follow up with everyone in the COE to see, who are participating in IB, and then we will start to build up the workshop together with a set of invited speakers, and then also contributed papers and a keynote, as we did in the past. Cool. All right, so I think we are at the end of the hour. If there are no other updates, then let's end here and have a great week ahead. And we hope to connect soon with everyone. Thank you, everyone, for taking the time, and looking forward to more exciting projects with the Autoware COE.
Okay, thanks, Rahul.
Thank you.
Thank you.
Thanks,
Take
Joe.
care.
Bye.
Everyone.
Bye.
Bye-bye.